No!
Recently, my Silksong video has gained lots more traction than I was expecting. I'm very grateful for this, and with this, a lot of you pointed out I had actually missed crucial details about the geology of the game in certain areas, whether that be due to the lore that had simply brushed my mind, or areas I'd forgotten, for good reason. Regardless, this means there's more rocks to cover. So this part 2 aims to cover what I missed and tie it into theories I came up with in part 1. So if you missed part 1, go check that out first. Now, where to start? The Pale Lake. A couple comments I received thought that the Pale Lake looked like columnar basalt, including my boyfriend, who hasn't reached this part yet, but he was certain that craft metal I showed last time was also basalt. And it's no wonder people think it's columnar basalt either. I mean, look at it. Columnar basalt forms when lava cools slowly inwards and contracts, which makes it fracture into columns. Why hexagons? Because hexagons are the bestigons. They're the most energy efficient shape that also tessellate with each other very well. But in order to know we're looking at basalt here, we have to prove what's in the Pale Lake actually is basalt. We know, after all, that basalt is very present in Silksong's geological record. But something that doesn't sit right with me about these basalts is not only do they look shiny, but the presence of bioclastic rocks interbedded with the columns. Now, it could be argued these bioclastics are actually a type of clunky looking lava. And with many columnar basalts arriving from slow cooled lava flows, this could make sense, if it weren't for the visible shells in these rocks too. But you know what's in the Pale Lake too? Craft metal, a columnar metal. This would explain the shininess alongside the columnar structure, but how did the metal get this big if it is craft metal? The Pale Lake is a very open space with lots of water, giving chance for evaporites to form from the minerals in the water. And since craft metal is described in-game as its own element, it's possible the water in this area contains unusually high amounts of craft metal. In fact, linking to Mount Vey's volcanism, this could have been carried from Mount Vey's volcanic metal deposits, then evaporated in the Pale Lake. This would also explain it being found all over the map, from water travelling from the source of Mount Vey, from glacial ice on it melting, or from water trickling down through rain, being heated by the volcano, carrying craft metal until it precipitates. So why are they so large? When given space, a mineral will be able to grow quite easily. We see this happen, for example, in geodes, where you get these very pretty crystals such as quartz growing in an empty space in a rock. So it's likely that the craft metal was able to grow due to the vast space the lake provided. The fleas have set themselves up for a very great trade business if Farloom doesn't crumble to bits, you know. Interestingly, a lot of the metal mines, especially in our glorious hellhole island Britain, come from caves that precipitate lots of iron ores from groundwater precipitation and mineralization from hot fluids, the processes I was just mentioning when relating to Mount Vey's water travelling. We also see this process happen in hotter areas with waters that produce three main evaporites, those being calcite, gypsum and halite, or salt. So, in my personal opinion, these aren't columnar basalts, but rather large craft metal ores. Of course, assuming I'm wrong and these are in fact basalts, I'd still like to explain to you what kind of setting you'd be looking at in case you still believe they are basalts. The most likely formation that would have these is a lava tunnel, formed when lava that travels underground cools on the outside, and the remaining still hot inside flows away before the intrusion can fully cool, leaving a large tunnel, often with these columnar basalts. When I visited one in Iceland, it was actually quite similar looking. Lots of columnar basalts, small gaps seeping through light, and a cave system forming in the darker areas with water deposits. So if these were still basalts, I think this is most likely what you're looking at. Let me know what you think. Basalt or craft metal? You know, I'm surprised I missed this since it's so obvious, but many of you pointed out that the sands for Karak used to be underwater. I did play the game, promise, and yes, when it was underwater it was thriving with coral. This also implies Falloom used to be in a tropical area, since corals are very picky about temperature and only let themselves grow near to the tropics. Don't tell me about Australia. The only proof that place is real is cold ones. However, we'll get on to in a minute why I don't think this is actually the case. The law states this place was once running with rivers, which we do see in Khan's memory. But rivers also imply this place wasn't in fact marine at all, so I honestly question how true these corals are. In fact, since some can still live in the now dying sands of Karak, my best guess is instead of being true corals, they're a type of bone that mimics coral in a way. This would also explain why 1. Bugs can live in the corals, and 2. The colour on them hasn't bleached, since last time I checked, the zooxanthellae living on coral's exterior shell can't live above the water. It also helps explain the sudden change from fluvial to dry sands, because it takes much less time for a river to run dry than it does an ocean, especially on the timeline of Falloom we're talking about. This also further cements my idea that we'd have bioclastic lithic conglomerates and sandstones in the area, since if it wasn't fluvial but rather marine, we could expect certain limestones instead. But being previously fluvial also adds a few more interesting details, the first being ripple marks. Ripple marks in sandstone are formed from the movement of water over the sand when it's still unconsolidated, preserving the movement of the water in its structure. In a river, more specifically, you'd be looking at asymmetrical ripples, since the water doesn't flow in two directions like an ocean, but rather multiple. There's also a chance for river crossbedding to be here, though it doesn't differ much from our dune crossbedding. And there's also potential for another type of structure called imbrication, where pebbles or bioclasts would be aligned with the flow of the river, which would tell us the direction it once flowed in. We could also potentially have new types of sandstones. For example, in alluvial desert fans, you get a sandstone called arkose, which is really rich in the mineral orthoclase feldspar due to less weathering of the mineral because it was rapidly deposited. But since waterfalls like this are very good at weathering and I don't see many muds present, I don't think it'd differ much from the more generic orthoquartzite sandstone, which is mostly quartz grains. Looking at the structure of the sands of Karak and blasted steps, I also noticed something interesting. Do you see how steep it is? This is more theoretical, but I think we could be working with a gorge here. These are formed from waterfalls like the one we saw in the tower, which carve out this steep stepped shape into the land. If these steep drops were in fact made by a waterfall, with the sand filling in what would have been plunge pools, we can infer the way that it once flowed through the sands of Karak and blasted steps, flowing from the coral tower, down the sands and through the steps. In fact, it completely explains how the blasted steps got its name, from the stepped landscape created by the waterfall. Definitely not my most insane theory since it's backed by the law itself, but the law doesn't really tell us where it flowed. Someone also commented that I missed out Vault Nest, which, yeah, I did forget about that place entirely. So let's quickly talk about Vault Nest. The materium description for this rock that makes up Vault Nest, called Vaulteridian, says it's hard stone able to catch, store and discharge electricity, which is interesting to say the least. It's not like we don't have electric conducting materials in geology, but most of the time they're metals, whilst Vaulteridian looks a lot like a gemstone. Now, I'm no electrician. Physics was my lowest grade when I took GCSEs for a reason, but a quick Google search tells me that some gemstones, such as tourmaline, are indeed conductors, and others can become conductors due to impurities in the crystal. So there is an explanation for Vaulteridian's properties. In fact, quartz is also listed as a conductor, which really surprised me. You do learn something new every day. And amethyst, a purple variant of quartz, definitely looks similar to the Vaulteridian crystals. So our possibilities are that Vaulteridian is either a localized name given to amethyst, since local names for gemstones and rocks are extremely common, or Vaulteridian is its own crystal that contains impurities in it that are high conductors, allowing it to store this electricity, or it's just its own conductive mineral. Last video I suspected Void could metamorphose rocks, but to be honest, Void confuses me a lot. Fortunately, quite a few of you came into clutch and told me some details about Void I hadn't previously noticed, and they also gave me quite a few more reasons to believe Void can metamorphose a rock. Unknowns to me, void doesn't actually need life to be in something to inhabit and change it, as the rocks in the void especially gain a new shape, becoming spiky and platy. In Hollow Knight, the hunter described the caverns around the ancient basin and abyss shifting as if the rock possessed its own will, so we can actually be certain void doesn't just inhabit life but rock itself. This also means we know more about properties of the rock in the void. It has to not only be porous but permeable in order for void to seep into it. Permeable simply meaning the pores are connected, so void has most certainly metamorphosed this rock. Another comment I got asked is if it could affect magma in any way then, which is a great question. After all, we see it right next to the abyss, and it's honestly really tricky to answer this one, especially with the fact I'm not actually a professional like some of you thought. Still a student, but it's not going to stop me from trying. The only way magma could be permeable is from volatile gases in the magma causing pores, but these likely wouldn't be connected, making it impermeable, since the rest of the magma is solid crystals. So it wouldn't be able to permeate the same way it did with other surrounding rock. It could be argued that the lava rising when Hornet tries to escape is because the void has inhabited it and is chasing her in some way, but I think this is more likely due to the massive explosion she caused. Earthquakes and explosions aren't really direct causes of eruption and lava rising, but a disruption definitely could set it off a bit, as well as the new space Hornet creates from opening up new tunnels. I think magma likely wouldn't be altered by the void therefore, but does it exist below the void? Yeah, I can't answer that one. There's a chance the void has a base, and below that base a lava conduit still travelling deeper, but unfortunately I think this is a question that has to remain unanswered, simply due to a lack of knowing. Others asked me if void could form oil shale, or a type of bitumen. Very good question to ask since it's made of many beings after all. As previously mentioned, the rock around here is permeable, which is a great quality in a rock to look for when trying to look for an oil reservoir. And in order for it to actually form oil, it needs to be put under high amounts of heat and pressure at a great depth. Both present? Depth is a questionable one since we don't know exactly how far down it goes, but kerogen only needs 2 to 5 kilometers to form oil, which isn't that deep, and I can imagine the void does reach this depth eventually. So especially towards the base of the void chamber, you may find it becoming a kerogen-like substance, which then turns into oil and gas, which could be stored in the reservoir rocks around the void. As for coal and bitumen, this is also quite possible, assuming that life forms in the void are carbon-rich, which I see no reason why they wouldn't be. This would of course occur at a lower depth than the kerogen, and will require lots of pressure, which again we definitely have from the weight of rock at depth. Whether or not it becomes coal or oil at all really depends on composition of the void. Coal is more carbon rich and kerogen is more hydrogen rich, but there is another way to guess whether it'd be coal or oil. Coal is more often found in a terrestrial environment such as swamps and bogs. Oil, on the other hand, is found more often in lake and marine environments. Now, neither of these are necessarily present in the void, but you could definitely argue the void is a lake, and it's a lot more closer in form to a lake than a terrestrial swamp. Coal is also associated pretty much only with plant matter, whilst kerogen is associated with many different life forms. And whilst these life forms are much smaller, I mean, bugs are small. We have to remind ourselves that everything we're seeing is a lot smaller than we're imagining. They're all just tiny little creatures. So with them being small creatures in a lake, in my opinion, it's more likely to form oil and gas from burial than it is coal. Someone also suggested I look at the materium and evaluate the realism of minerals and their real-life counterparts, which I think is a fun idea. I've already covered craft metal and volturidium in this video, so I'll be skipping those out, but let's look at the rest, starting with flintstone. Ah, my good friend the flintstone. In the last video I was confused as to why it said it was a type of slate, but this actually seems to be a descriptor only fitting the weapon, so we can completely scratch this out of the equation. Looking at its description, it does seem to be what I imagined last video, being something similar to coal and sulfur due to its long burning properties. Someone also suggested it can contain oil, and whilst I see the reasoning, I think it's likely not going to, since it doesn't look like a great host rock for oil at all. This is also combined with the flint gem, which looks strikingly like sulphur with these bright yellow crystals. Sulphur is notoriously flammable and explosive, taking any chance it can to explode, so it's no surprise the description says it produces sparks when abraded and can explode when dropped. Talk about volatile. It's likely then that the deep docks contains high amounts of sulphur, possibly carried in by our volcano waters again, although sulphur as a precipitate requires a reaction to be precipitated, unlike basic metals and salts. This would explain the explosive nature of the flintstone, since it could contain small amounts of sulphur precipitates, and it's possible the flint beetles that contain this gem have it stored in them from eating sulphur-rich grasses, or just straight up licking the sulphur off the walls themselves. In their needling dialogue, they say, "Find the glint, seek the gleam," which could be implying that they're looking for the sulphur on the clay walls for consumption, not dissimilar from what mountain goats do when they seek out salt on mountain walls to lick off. Magnetite we briefly touched on in the last video due to it being evidence of Mount Fay being a volcano, but I wanted to touch more on the differences between in-game magnetite and real-life magnetite. Magnetite in real life is an iron oxide mineral that when allowed to grow will produce these grey octahedral crystals. I ended up googling silly stuff like, can magnetite float in air? To show you all the differences and can confirm it still doesn't float. It's really high density. But it can be forced to float using spinning magnets or superconductors, funnily enough. I don't think Mount Fay is full of spinning magnets, but you never know. The in-game magnetite is also really, really blue, and whilst I did say magnetite was grey, some does appear to be blue. A fair warning though, if you Google blue magnetite you will find image of straight up dyed fiberglass. But there does appear to be some authentic blue magnetite specimens, though rare. Lastly, I wanted to cover a few random bits of information I got asked about or forgot to add last time, starting with Mount Fay, again. What I forgot to mention last time is about the actual glacial parts of Mount Fay, as whilst I did cover the volcano, some of you may be confused as to why Mount Fay has ice if it's a volcano. On volcanoes that are more dormant, whilst they may have activity underneath the ground, glaciers aren't too uncommonly forming. We see it for example in Iceland, where glaciers settle on top of the volcano from rainwater collecting, often in the vent or around it. This also has a few catastrophic implications for Farloom's future if Mount Fay decides it wants to erupt again. When volcanoes with glaciers on erupt, the water on the glacier melts, producing a lahar, a type of volcanic water flow carrying ash and debris at high speeds. So if the void doesn't destroy Farloom, that sure will. Hey, at least the sands of Karak will be hydrated again. Maybe a tangent, but lahar flows are so cool when you see the actual rock. And confusing. I found one on a field trip to the Isle of Arran, and I nearly went damn insane trying to figure out why the igneous rock had chunks of sedimentary stuff in its matrix. Glaciers also imply we could have had quaternary deposits such as tillite on top of the volcano, made from muds and clays cementing bits of rock the glacier carries. But the fact that this glacier looks relatively new and I don't see much unconsolidated sediment means this likely needs another couple thousand years to build up. Next, someone asked me if the weaver den in Bilewater saying "sister, spun in salt and stone" had any relevance and if this all relates back to the Pale Lake. And I think it could. As I mentioned before, salt is one of the evaporites commonly produced from heated water. It's the last of the three evaporites to be produced and is more commonly associated with oceans and desert lakes. We don't have much evidence of salt deposited in Silksong itself, but since there's huge deposits of water around, it's not impossible for a previous deposit to have evaporated and left behind salt. It's possible this den being in Bilewater then, that before the waters were contaminated, they were able to evaporate salt somewhere, which we now wouldn't see due to all the grime around the place. Yuck. Finally, another commenter said it appeared as if there were ammonites in some areas such as Bone Bottom. Whilst I personally interpreted these as bookshells, like most things in these rocks, it would have some pretty interesting implications if they were. In order for ammonites to be here, they'd either have to have been deposited in a marine environment some 100 million years back, or they're derived fossils, a term used to describe fossils in a rock carried by different processes from its original source rock to a new host rock. We don't have much evidence of Silksong being previously fully marine, the closest being the sands of Karak, which I mentioned were likely actually a waterfall, but the presence of a waterfall does imply a force that could carry ammonites from their original rock source to a new one. These waters would have plucked the ammonites out, and we'd expect them to be broken due to high energy. Alternatively, the glacier could have actually been bigger than we thought, which also can carry ammonites, as seen in places such as the Holderness Coast, where fossil hunting in the Tillite is actually quite easy. But this would imply the glacier once covered the whole area and then just receded to Mount Fay, which whilst not unheard of, I think it's more plausible that they were carried by the river, which could have flowed for longer than we thought. And this wraps up part 2. I'm surprised at how much I missed, but I'm really glad I was able to cover it more. I think Silksong's geology is actually quite interesting, even if quite difficult to interpret due to it not being a main focus, and it's clear you lot really loved it too. Thank you for all the support and subscribers. I woke up with a real surprise the night after I posted it. Whilst I'm here, I would like to say something important. Currently, our geology education department is under threat from budget cuts, and I care deeply not just about my education, but future generations' education too. So in order to support the union that's fighting against these budget cuts, I've opened my commissions up to try and encourage donations. By donating to our union, you can not only help support our department, but get some sweet, sweet art as a thank you. So make sure to check out my pinned post on my Instagram, The Rockumentarist, for more details on that. As always, thank you so much for your support and time. Make sure to subscribe and follow my Instagram for more geology posts and updates, and eat 5 rocks a day for their good nutrient contents. Bye!